Hey guys, welcome back to my channel. Today we're going to talk about the DHCP protocol, Dynamic Host Configuration Protocol. This is an application layer protocol which is used for allocating IP addresses to the end user hosts. Each host in your particular network will be assigned a unique IP address based on the pool of addresses the DHCP server has. So instead of a network engineer manually allocating IP addresses to its devices in the network, we can use the DHCP protocol where the DHCP is configured on each of these devices and we have a DHCP server in the network. These devices will request for an IP address to the server and the server will provide them with an IP address from the list of available IPs. It will also provide them with a subnet mask. Sometimes it can be used to provide the gateway address of the network. It can be also used to provide the DNS address and the many other things which it can provide. So so this is what the DHCP protocol is basically used for. Okay, it's centralized way of maintaining its IPs for a particular host in the network. So how it works is it follows a DORA sequence, which is discover, offer, request, and acknowledge. Okay, so let me show you over here. So let's talk about the DORA sequence or the DORA process where we have the discover, offer, request, and acknowledge. Let's say we have host A. Okay, we have host A and we have a DHCP server in the same network, right? Host, or let's for an example, right? DHCP server can be thought of as a Wi-Fi router in your house, and host A can be thought as a new device that is connecting to the Wi-Fi router. So when the new device is connecting to the Wi-Fi router, the DHCP server, which is the router, will provide an IP address to the new host which was trying to connect, right? So think of it in that way. Okay, so what happens over here is we have host A, right? Host A has source IP of 0000 because it does not have an IP address yet. It has a destination IP of 255, 255, 255, 255 because that is the broadcast address. Source MAC is AA of this particular interface, right? And we have a destination MAC of FF and FF, which is basically a broadcast destination MAC. So the DHCP discover message is a broadcast message which is sent to all the devices on the network. Okay, now this DHCP request message will be reached. It will reach the DHCP server. DHCP server will see that this is a DHCP request message from all the fields of the packet in the header, and it will see that it is received from the client ID of host A. Okay, so what the DHCP server will do, it will check its pool of IP addresses and it will see that it has IP addresses left to be offered. So it will choose one of the IP addresses and it will say that, okay, you know what, I have an IP address there and this can be offered, so let me offer this IP address. So that will be say 172.16.32 network, and let's say the IP address to be offered is dot 121. Okay, now client ID is host A, right, as it has received from the client, and server ID will be let's say this is host B. Okay, let's say the client server ID is host B. So the server ID will be used to identify if there are multiple servers on the same network. Okay, you can have multiple DHCP servers. Then now we know the destination MAC will be AA because that's our host A is a destination for the offer message. So this is an offer message which I'm formulating over here. Okay, AA, and the source MAC is its own MAC, which is BB. Destination IP will again be, it will be 255.255. It's a broadcast at layer 3, and source will be 172.16.32.1 or .12, let's say. Okay, now this is the offer message that is now sent to, okay, offer message is now sent to the host A, to the DHCP client. Host A is nothing but DHCP client. Now host A will see that, okay, this is the this is the offered IP 172.16.32.121. So what the host A will first do is it will send a gratuitous ARP message is sent. It's a broadcast message which is sent with the IP address of which is the offered one, which is 172.16.32.121. it basically makes sure that no other device on this network has received this IP address and it is not in use in the network. If it is in use in the network, then that particular host will reply to this message, right? So once it does not receive a message for a certain amount of time, it can conclude that, okay, nobody is using this particular IP in the network. So what it will do is it will send a request message. Okay, a request message will be sent from the DHCP client to the DHCP server saying that, okay, I accept this particular IP address and I would like you to assign me this IP address. Okay, so the DHCP server will be like, okay, since you have accepted it, now let me start the lease time for it. So maybe as in part of the DHCP configuration, you're setting the lease time to be 72 hours. So you send an acknowledge message, okay, saying that, okay, now you can start using this particular IP address and your lease time has been started. Okay, along with this, the DHCP server can also offer the gateway address. It can also provide them with the DNS server address, and a few other things can also be offered over here. I'll share a link on more details on what all things can be offered in the message, and you can just go through it. But this is how the DORA process work, where the DHCP client will first send a discover message, then an offer message will be sent from the DHCP server to the client. Then it will check if that IP address is being used anywhere. If not, then it will send a request that IP to be assigned to host A to the DHCP client, and the DHCP server will acknowledge and start the lease time, saying that, okay, now you can use this IP address for this particular lease time, and these are your other whatever, the gateway address, and this is your DNS server IP. Will be sent to the host A, and the host A can start using the IP address. So this is how the DHCP servers allocates the IP address to a particular host which joins the network. And this is, there is also a possibility that all the IP addresses in that pool has been allocated already, and a new device comes and it does not have any IP address to assign to it. Then what happens? Right, that is also a possibility, and then in that case it will be sending a negative acknowledgement message saying that we don't have any more IP addresses and I cannot assign you a new IP. So that is a DHCP negative acknowledgement message. Then there is a DHCP release message where a DHCP client sends a DHCP release packet to the server to release the IP address and cancel any remaining lease time. Okay, that's DHCP release. And I think there are a few more DHCP messages. I'll again share the link. Please just read through it. But this is the entire the DORA process which we're talking about to learn how the DHCP server assigns an IP address to a DHCP client. Please do let me know if you have any comments. Please like, share, and subscribe, guys. Thank you.